Okay, a bridge is to be built in the shape of a semi-elliptical arch and is to have a span of 136 meters. The height of the arch at a distance of 60 meters from the center is to be 32 meters. Find the height of the arch at its center. What in the world? Well, you know what we want to do on this one? So basically, let's think about this question for a second. They're saying, okay, what is, first off, what's a semi-elliptical arch? What's a semi? What's a semicircle? It's a half a circle, right? Semi means half. So semi-elliptical arch means half an ellipse. So we're talking about like that. So we got some kind of bridge that's half an ellipse. I mean, it's not half a circle, but it's half of an oval, half of an ellipse. It's an arch. And it has a span of 136 meters. So there's 136 meters is like how wide it is. That's its span. Not its span, but its span. Okay. The height of the arch at a distance 60 meters from the center. That's weird. So if here's the center, you go 60 meters this way, and the height of the arch there is 32 meters. That is weird. Find the height of the arch at its center. So find H right there. What's the height at the center? How do we find that? I mean, are you kidding me? That looks like some difficult and fancy geometry, doesn't it? I mean, how in the world? Well, you know what we need to do? I think you probably already know. We need to put this on an axis system, and then we'll use the ellipse equations that we have learned. Now, wait a minute, why? Because it's so helpful to us, because we've learned equations that work on an axis system. The trick is, you might be thinking, and it would be a good thought to be thinking it, you might be thinking, there's no axis system here. When you look at a bridge, an arch, there's not an axis system there, right? There's not. It's made up, like all the rest of math, like I'm always telling you, right? This is a perfect case in point to see how math works with the real world. There's no such thing as an axis system on a real life bridge. You don't look at it and go, yeah, I see the x-axis. It's right there. I see the y-axis. It's going up into the sky. No, we're making that up. We're making it up. Why? Because it helps us, huh? Math is made up to help us do things that are real. All right, so I'm going to stick that bridge. Now, where am I going to put it? Would it be good to like put it over here? No, we want to put it in the middle, of course, right? I'm going to put it smack dab in the middle. Let me see. I don't know how far to go. I'll go here. Well, here, let me go further. Let's go here. Here. I'm just going to go, I'll go to like, I don't know, here. I'm just going to do best I can here. So, like that. All right, not bad because of that tool. All right, so there's the half ellipse, sort of. All right, and what do they tell us? They tell us that the thing is 136 meters. So it's 136 meters is the total span. So you know what we need to do with that, divided by 2, don't we? Well, we can do that in a minute. Okay, and it says at a distance of 60 meters, so like way over here, if we go way over 60 meters to the right, the bridge's height, right? 60 meters from the center, the height of the arch is 32. That's what they're saying. It's, if you go over 60 meters, you'll find a height of 32. Okay, we good so far? So now that we have placed this thing right on the center of an axis system, now we can use our equations. Let me grab our equations. Let me go over here to our notes. We've got a graphing an ellipse centered, this is example 5 notes, graphing an ellipse centered at the origin. So let's grab those and let's pop them in here and take a careful look at them. So how do you graph an ellipse centered at the origin? You know, right? If you have an equation like this, right? From the center, go right and left, the square root of the number under x. The number under x. You go right and left 8, because that's the square root of 64. Up and down 5, because that's the square root of 25, right? That's how you do an ellipse. And we have a half an ellipse. We have the top half of the ellipse. Okay. So we need an equation. So we have something like x squared over whatever, call it a squared, plus y squared over b squared equals 1, don't we? That's the equation of the ellipse. That's the half ellipse equation. Okay, do we know anything at all about this? It's centered at the origin, so I'm just doing that. And now, well, we do know how far right it goes, don't we? We can take 136, divide by 200 calculator, get what, 68, I think, 120, 16, yeah, 68. So it goes, so it must go 68 to the right. All the way over here must be 68. And it must be back this way, negative 68, because 68 and 68 make the total span of 136. See what I did? I just divided 136 by 2. Okay, so what? Well, look what it says here. Look at the original notes. From the center, right and left, the square root of the number under x. So this number that goes under x, the square root of that number tells you how far right and left to go. In other words, if you know it's over 8, you could square that, 8 squared, and that would tell you the number under x. You see? So that's what I need to do. I know this is 68. So therefore, this is going to be 68 squared, isn't it? I can just put it right there. I don't even need to know what that number is right now. Whatever, our calculator can figure it out. But it's got to be 68 squared. Again, one more time. You're seeing it from the notes. However far over, like 8, squared is 64, or vice versa, the square root of that becomes 8. Either way you want to go, right? Okay, be good. Now, how do we get the number to y? Well, you just go up. Well, I drew it, but I don't really know. In fact, that's precisely what they want me to figure out. They want me to find out what b is, how high it is right at the center, right? Find the height of the arch at its center, which is going to be the b, right? However far up it goes, square that, and you'll get what goes under y, right? Look at the notes if you're not clear on that. From the center, up and down the number under y, right? So see, it goes up 5 and down 5. Squared is what? 25. See, the number under y is how far up. Squared is how far up and down, or vice versa. The square root of the number in the equation tells you the thing up and down. So if this is 5, then squared goes there. If it's b, squared goes there, right? Same thing. So this b and b squared goes right there. So that's what I'm trying to find. That's actually my goal. Find b. Let me just write that. Find b. That's the height at the center, isn't it? Which is what they're asking for. How tall is that elliptical bridge at the center? Well, there's one piece of information I haven't used, and it's right here. This is the point over 60, up 32, and it's on the ellipse, which means it's got to make the ellipse's equation true. Are you tracking with me? How'd I get that? Because they told us that at a distance of 60 meters from the center, if you go over 60, the height is 32. So in other words, they're planning ahead of time to build this bridge so that, whatever semi-trucks can go under it. Say the semi-trucks need a clearance of 32 feet, and the freeway lane is going to go all the way over 60 feet. Say there's 60 feet this way and 60 feet that way for the cars going this way and that way underneath this bridge. Well, 60 feet over, they've got to make sure they have a clearance of 32 feet of height for the semis to not hit the top of something. So that means this point right here, over 60, up 32, has to be an XY point that is on the ellipse. And what does it mean if you're on any graph at any time? That means your X and Y plugged in make the equation true. That's the membership requirement, right? That's how you get to be a dot that's on a graph. You make its equation true. So if I take that 60, plug it in for X, and I take that 32 and plug it in for Y, I'm going to get 60. Here, this will be 32 squared over 68 squared over b squared equals 1. And now I can solve that equation for b. You see? Let's do it. Now we just need to solve for b, and we'll have our answer. So I'm going to do this. This is going to become 3,600 over 4624, and 32 squared is 1,000. 24 over b squared is 1. We're good so far. Now you know what to do, right? When you have fractions, with an equal sign problem, what do? Step 1, multiply all the terms by LCD over 1. And the LCD is going to be 4624b squared over 1, right? The LCD has to use all the denominators. That's the common denominator, right? You got to use them all. All right. So let me bring that down and try to do that neatly and cleanly because it can get a little bit of 4624 plus 1024 over b squared equals 1. I'm going to multiply through by what? 4624b squared over 1. Same thing here, 4624b squared over 1. Here, 4624b squared over 1. All right, what happens? 4624 cancels out. And b squared cancels out, right? And we get 3,600 b squared plus 4624. I'm getting lost. Times 1,024. That's big, ugly. Equals 4624 b squared. I'm gonna multiply these guys right here. Gonna be a big number. I'm getting 4734. Whoops, come on. 4734976 plus okay, and then subtract 3,600 b squared from both. What do we get? 1024 b squared. This is 4,734,976. We are so close now. Now divide by 1,024. Boom, boom. I'm getting 4624, and then last step, root it, and we get the square root of that, which is 68. There it is. B is 68. So we got, now you might say, wait, last time we just left b squared as b squared. Why are we rooting this one? Well, because this time we don't want b squared, we want b. Well, how do you know? Well, look at the picture. We want b, not b squared. Is that getting confusing? That's where you need to spend some time. The stuff doesn't come to the casual. It comes to those who spend time. So look back at the notes. You got to really spend time getting comfortable with that. So in other words, the number to the top, like the 5, that squared is what goes under the equation. See that connection? Or vice versa, the root of what's under the equation is how high this is 5, right? There's this back and forth relationship, but it's not equal, it's squared. 5 squared is 25, or the root of 25 is 5, right? So in this case, I want to know b. I want the actual height up to here. So to get that, to get b, this is b squared down here. To get b, right, because whatever the height is, it's squared. To get b, I've got to root it, and it's 68. So the height of that arch at its center must be 68. And what are the units? It's meters. Everything was meters in this problem. See, meters here, meters there. Here a meter, there a meter, everywhere a meter. So it's meters, 68 meters. So when they build this thing, this is how engineers would calculate it out ahead of time. They would say, we got to build this elliptical bridge that has a 68 meters high in the center. And therefore it'll come down and it'll be 32 meters high at 60 feet to the right, like we need. It'll hit over here at 68 meters all the way to the right there. That's what it's going to have to be on that. That's interesting. It's interesting that the answer, 68 meters in the center, came out to be exactly how far it is over here. This is 68 and this is 68. That means it's actually a circle. Do you realize that? The height here and here, those are the same. So it's a perfect ellipse, better known as a circle. An ellipse that is the same height as it is width is called a circle. A circle is the perfect case of an ellipse, like a square is the perfect case of a rectangle. So it's actually, this one turns out to be just a circle. It's such a perfect ellipse. But that's a coincidence, doesn't always have to be that way. There we go.